right, class, we are basically reviewing the scientific method, which we had started on in the beginning of the year in August. Not sure if you guys remember, but we did start off with the scientific method, all right, and its components. But we're going to go back into review the scientific method and its components to make sure we have a clear understanding and a mastery over what we've reviewed and talked about in the beginning of the year. Okay, so let's begin. All right, I'm pretty sure you guys are familiar with this PowerPoint, which you've seen, or these slides you've seen in the beginning of the year. All right, so this should be very familiar to you. If not, then we will go over the lecture and go over some of the key terms and key things that are in this introduction. And let's go ahead and begin. All right, so introduction to science and the scientific method. Okay. All right, it says, what is science? The goal of science is to investigate and understand the natural world, to explain events in the natural world, and to use those explanations to make useful predictions. All right. 1. Science deals only with the natural world. Okay. 2. Scientists collect and organize information in a careful, orderly way, looking for patterns and connections between events. And last of all, well, not last of all, we have 2 more to go. 3. Scientists propose explanations that can be tested by examining evidence. And last of all, science is an organized way of using evidence to learn about the natural world. Okay, and as I move my mouse or my precursor around the screen, as you can see here, these are 2 examples of the natural world. Okay, we have a frog here. Okay, and it could be a particular frog. It could be a different species of frog. Okay, but this is a frog, and of course you also know that this is a giraffe. Okay, these are 2 organisms that are a part of the natural world. Okay, that scientists observe, make emphasis, and collect data from. Okay. How is science done? Science begins with an observation. All right. This is the process of gathering information about events or processes in a careful, orderly way. Data is the information gathered from making observations. So last year, last year, and in August, class, do you remember when you guys had to do an assignment, you had to observe by using your 5 senses? Okay, you have to observe by using your 5 senses the natural, the outside part of the world. Okay, and we did that by actually going into the middle of the school. Okay, going into the middle of the school, where right there in the courtyard, okay, outside those doors, remember in the beginning of the school year, we observed nature. Okay, now the nature wasn't huge. It wasn't a lot of things for us to observe as far as a field or going outside of the building, but we were still out in the natural world. You were still able to observe different things like ants, plants, butterflies, mosquitoes. All right, you was able to not only see and feel different things, but you was also able to hear. Okay, you heard things of nature as well, crickets, or even some of us heard things outside of the school. Okay, that we probably seen or heard up in the sky. Okay, I think someone from another class or from a previous class that they heard some type of the ventilation sound coming from the air conditioner from the school, or they heard some jet or something that flew above them, all right, in the sky. But these are things that we observe outside of our environment, okay, or inside of our environment. It could be within or it could be without. Okay, but these are things that we observe, but mainly nature itself. So when you guys did that activity in the beginning of the year using your 5 senses, you was able to observe nature itself, even the soil, the dirt. Okay, all right. Oh, okay. Let me go back to data. Now, when you also observe those things, you also was able to collect data. Remember those sheets, as you observe, you also had to collect data and write it down, and then compare and contrast your information when we came back into the classroom. Okay. But that was the activity that we did in the beginning of the year for the ones who were not here with us in August. Okay. Using the scientific method and its components. All right. There are two types of data: qualitative data and qualitative data. Now, quantitative data deals with numbers and are attained by counting or measuring. Okay. Qualitative data are descriptions and involve characteristics that cannot be counted. Okay, I'll say it again. Quantitative, numbers, and are attained by counting or measuring. So we know quantitative deals with numbering. Okay, numbers itself, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and measuring. Okay, 50 centimeters, 100 kilometers. All right, 2 liters. Okay, let's deal with measuring, using numbers to measure certain objects or things. Qualitative data description and involve characteristics that cannot be counted. Okay, so something that is an object. Okay, that is a object that has characteristics to it. All right, the table, the classroom itself, the door. Okay, the board. Things that are not numbers, the actual mass objects, objects that made out of mass. All right, material objects. Okay. That is what qualitative data is. Now, a hypothesis is a scientific explanation for a set of observations. Okay? Hypothesis. A hypothesis must be stated in a way that makes it testable. The hypothesis is just a possible answer to a question, and it must be thoroughly tested. So, before an hypothesis comes, you have to form a question. Okay, which we want to get into some explanation on the next slide. But in order for a hypothesis to come about, a question has to be formed, and then your hypothesis will be answering that question. All right, but when you're answering that question has to be that that statement, which is your hypothesis, has to be testable. All right, so you have to rewrite it in a way, or write it in a way that statement can be tested, okay, as you answer the question, okay, to the entire experiment. So let's go in a little bit more detail with that. All right, scientific method. Okay, the scientific method is a series of steps used by scientists to solve a problem or answer a question. The steps of the scientific method: 1, all right, observation, asking the question. All right, you must observe a phenomenon or a problem and ask that question about a phenomenon or problem in order to move on to the next step. All right, so observation has to happen, and then once you observe, you have to ask a question. All right, next, form a hypothesis. Again, once you observe and once you form your question, now you have to form a statement, a testable statement, which is your hypothesis. 3, design a controlled experiment. Okay, design a controlled experiment, dealing with your variables. Okay, you have your controlled experiment and you have your variables. All right, things that you can control within your experiment and things that you cannot. 4, record and analyze results. All right, which is basically your data, the quantitative and the qualitative data. Okay, things that are dealing with numbers that you can measure, or you're using some type of measurement, and objects that are just made out of mass, which you can touch, feel, see, or either smell. Okay, and next we have draw conclusions. Okay, to sum all that information, sum all that data up. And once we sum that data up, now we can conclude. All right, we can come to a conclusion about the experiment. All right, based on the data and based on our hypothesis, to see if our hypothesis is correct or wrong. Okay, that's what we're trying to figure out. Is once we do the experiment, is our hypothesis is going to be correct or wrong? All right, step 1, observation, asking a question. Okay, a problem or a question must be identified. Again, you must have some type of problem or question in order to formulate these different types of components of the scientific method. So, for example, how much water can a root hair observe? Okay. Why does a plant stem bend toward the light? Okay. What effect does temperature have on heart rate? Okay. So these are questions that can be tested. Okay. These are questions that can be tested. But before these questions can be tested, we have to form a hypothesis. You know, some people say an educated guess. All right. And that's fine. That educated guess can be right, can be wrong. But in order to find it out, you have to actually test it, which, in other words, form an experiment. Okay. So we have the hypothesis. It says step 2, form a hypothesis. Hypothesis, a possible explanation to the question or problem. Okay. It is simply a prediction that has not yet been proven or disproven. It must be stated in a way that is testable. A statement is considered testable if evidence can be collected that either does or does not support it. Okay. So it can be tested based on your observations, your experiment. All right. That'll let you know, that'll be your data and your information that let you know if that specific problem, all right, that specific problem or question can be, well, not tested, but it lets you know if that specific problem or question is right or wrong. Okay. Based on your results. Your results will come from your data. All right. It'll come from your data. But let's continue on. All right. Step 3, designing a controlled experiment. 1, says the factors in an experiment that can be changed are called variables. Okay, I'll read it again. The factors in an experiment that can be changed are called variables. Some example variables would be changing the temperature, the amount of light present, time, concentration of solutions used. Okay, these are things that you can actually, in other words, control. All right, you can control these. The factors in the experiment that can be changed are called variables. All right, and you can change these variables. Time, you can change the time in the experiment. Okay. Concentration of solutions, you have control over that. Okay, you have control over the solutions that you put within an experiment, within a test tube. All right. Temperature, you can control the temperature. All right, I can control the temperature within this room by basically moving the dial up or down. All right, putting on a certain temperature measurement. Okay. Number 2 says a controlled experiment works with one variable at a time. If several variables were changed at the same time, the scientists would not know which variable was responsible for the observed results. Okay, so again, your experiment has to be controlled. Okay, it has to be controlled and it has to be in order. All right, you don't want multiple things happening all at one time. Okay, that would throw your data off. Okay, that would throw your data off and it'd be hard to get results to come to a conclusion. Number 3, in a controlled experiment, only one variable is changed at a time. All other variables should be unchanged or controlled. Okay. So again, all other variables should be unchanged or controlled. All right. But again, some of these variables we can change. For example, like I said, temperature, the amount of light present, time, concentration. Those are variables that can be changed. All right. An experiment is based on the comparison between a control group with an experimental group. Okay. These two groups are identical except for one factor. The control group serves as the comparison. Okay. It is the same as the experimental group, except that one variable is being tested. Except that one variable that is being tested is removed. The experimental group shows the effect of the variable that is being tested. Yes, of course it does, because it's the group that you're doing an experiment on. Okay. Which makes sense as well. All right. Example, in order to test the effectiveness of a new vaccine, 50 volunteers are selected and divided into 2 groups. One group will be the control group and the other will be the experimental group. Both groups are given a pill to take that is identical in size, shape, color, and texture. So again, we have 50 people that are selected and divided into two groups in order to test the effectiveness of a new vaccine.